So now that we've laid out some of the ideas, let's go ahead and just start doing an example and kind of see how this works. So again, we have a side-side angle, right? So we have an SSA oblique triangle situation going on. We know that the angle B is 16, but I don't know what the angle A is, and I don't know what the angle C is, and we also actually don't know what side A is. All right, so we know what side B is. We know what, we know what side B is. We know what side C is. All right, so we've got that information working for us at this advantage. So the good news is we can find right C right away. That's basically due to the fact that we have the ratio here. So the sine of 16 degrees over 17 should be equal to the sine of C over 24. So we can actually find the value of C at this juncture. So doing a quick cross multiplication, or heck, just multiplying both sides by 24, we get that the sine of C is 24, right, times the sine of 16 all over 17. So our C value is the inverse sine of whatever that is. Okay, so there's where we're at. So we'll now turn to our calculator, right, and we'll basically find, right, I want to know the inverse sine of 24 times the sine of 16, and that's being divided by 17. All right, and let me close my parentheses. So when I do that, we get 22, it looks like 0.9007. So C is 22 let me read that again, 9007. So we're guaranteed then, since we found a value, this is basically saying that this value right here is less than 1. All right, we do have at least 1. So there's a possibility of 2, but we do have at least 1. We were able to find it. So let's just go ahead and finish this off, and then we'll talk about the second one if possible. So now that I have C, right, we can now find A, right? A plus B plus C should be equal to 180 degrees. So if I fill in what I know, A, that's 16. We just found this to be 22.907 equals 180. So our A is 180 minus 16 minus 22.97 degrees. So when I put that in my calculator, 180, minus 16 minus 22.9007. So our A is 141.0093. So A is 141.0993 degrees. Okay, so we have that. So that and that, right? And so to finish this off, we just need to find the side A. And so what we can do there is use the fact that the sine of 16 all over 17 is equal to the sine of A, which is 141.0993, right, all divided by whatever A is. And then the math is pretty much the same that we were doing in the first case, cross multiply and divide. We end up getting that A is 17, the sine of 141.0993, all divided by the sine of 16. Okay, and so our A in this case, right, is we've got 17 times the sine of 141.0993, and we are dividing that by the sine of 16. So what I'm getting out that is 38.7304. Okay, so far so good, right? When we put that together, this A is set as 38.7304. The angle A is 141.0993, and the angle C is 22.90 0.07. And so that is for sure one solution, and it satisfies the largest angle, right? Excuse me, the largest angle has the largest side, the smallest angle has the smallest side, and the intermediate angle has the intermediate side. All right, so so everything looks good. But what about a second possibility? How do I find if there's a second possible? Well, again, for our angle C that we have, right, let's go ahead and find its supplement to C, right? And so let's call that C star, if you would. So C star would be 180 minus the C value that we got. So that's 22.9007. So another potential C star, right, we would end up getting 180 minus 22.9007. All right, and that's 157.0993. So here's another potential answer. Again, the idea is we're using the fact we know what's happening on this side, right? That's 22.0993. And if we look at the reference angle on this side, the other angle that's a possible answer is 157.0993. The sign is the same for each one of these. So does this situation, does that angle create a new one? So that means, right, what's our A star? Well, A star should be 180 minus the B that I have minus this angle that we have up here. And if this is well defined, then that means we have another side. So 180 minus 16 minus 157.0993, and what we get is 6.907. So there is another angle, so 6.907 degrees. So it does turn out that there is another triangle, right, with C equaling to that very large obtuse angle, A being a very, very tiny angle, right? And so that means we need to go work and find out, well, what is little a star for this secondary triangle? And so that's basically the, again, the sine of 16 degrees over 17 would equal the sine of 6.907 all over little a. Cross multiplying and dividing, we find that this, I guess it's a asterisk, right, would be 17 sine of 6.907 sine of 16. So this secondary one, right, would be 17, the sine of 6.9007 divided by the sine of 16. And so what we're getting here is this is 7.4102. So there are actually two angles here because the math works, right? There's the angle that I get in quad 1 creates a triangle, and the angle that I get in quad 2 creates another triangle. This one would be this guy right here. So C is a pretty big angle. It's 157.0993. B is still 16 degrees, and A is really tiny, 6.907 degrees. And then this side is 17, this side is still 24, and this side, it's not to scale, my scale's off, sorry about that, but this side is 7.4102. And again, we see the largest side, the largest angle has the largest side, the smallest angle has the smallest side, and the intermediates match. So there's a situation there, and there's a situation there, right? Because the angle that we got in quad 1, that's usually the one that's guaranteed if everything exists, right, has a matching one over in quad 2 that also creates a situation that exists. We got another A star that's still very possible. It's still within that 180 degree motion. Okay, so that one, the ambiguous case 2 that we had, actually created two possible answers. Which one we use? Well, depends on the situation we want, right, or that we're observing. But there are two for a given angle of 16 and a side opposite being 17 and a side opposite being 24. There's two possible triangles, this one up here and this one down there. All right, so much more to do. We'll see some more examples where we just get 1 or none or 2 again. Let's do that in some videos coming soon.